So there's going to be a activity afterwards, and this is just sort of like hopefully, and I only have like 15 slides here, so it's sort of like a quick introduction and then an activity, which should help make the introduction make more sense. So, all right, hey guys, again, I'm Sam, and I'm going to talk about version control, which is sort of really a very pragmatic, non-sciencey thing, but if you're working with Rosetta, it turns out to be really important. So the question I have before we go any further, who here has used any kind of version control system ever? All right, what have you guys used? Git? Anyone used something that's not Git?
SVN.
SVN? Okay, anyone else used like RCS or CVS or something like ancient? Perf Force? Okay. I'm sorry. All right. So if you've used Git, then this will probably not be the most interesting hour and a half of your life. I'm sorry. If you've used SVN, what I would recommend is sort of trying to forget what you learned about SVN. Because Git is better, but Git has commands that have similar names to SVN commands, but they do very different things. So just don't. And I have some doc links at the end of this presentation that will help you in forgetting what you have already learned. But for the rest of you, let's talk about version control. So why do we need version control in the first place? So in Rosetta, we have, at any given time, 50 people editing about 2 million lines of source code, and none of them are really talking to each other a lot. So we need to keep track of who is changing things, what to do when two of us change the same file at the same time, which happens constantly because we're all sort of modifying things, and maybe I'm working on something and you're working on something, and we have to touch the same class. So what do we do then? All right. The other thing is we're all making changes, and we want to be able to back them up, right? So if your laptop catches fire, you don't want to have to just quit your PhD. And also, when someone introduces a bug, it would be really nice to be able to figure out, when did that bug actually get introduced, right? And who did it and what happened. And when you have lots of changes being made, having version control makes that easier. So Git is a way of doing version control. And Git is something that historically we've used SVN in the Rosetta community. Long time ago we used CVS, but for the past decade or so we've been using SVN. And on May 1st we're going to be switching to Git. So we figured since you guys are here a week before we make that transition, we could sort of get you all started early. So Git has a lot of features that make it really good for doing version control in a community like ours. So basically, the first thing you do when you work with Git is you do a clone of the repository. So when you do this, you actually are copying all of the history of the entire project onto your computer, and it gets stored in this little compressed directory. And then what you do when you make a change is you make a change to the local clone that you just made. And then when you've made made a bunch of changes that you want to make, you can then take those changes and push them to the remote repository. So basically, you're copying the repository, doing something to it, and then synchronizing the changes to the repository with the remote repository that everybody's going to use. Yeah?
What's the difference between a clone and a fork?
Okay, so we're going to get into that. All right. So and that's sort of so basically what you're talking about is on GitHub there's this fork button. So that sort of makes a clone that then you can then make changes to and then merge back into the thing that you cloned from. So that, if that makes sense. And when we're talking about, since everybody is cloning the repository and changing the entire repository, we call this distributed version control. If you're used to using SVN, in SVN you check out a single version of all of the files, make changes to that version of those files, and then commit those changes back to the repository. So you have one repository that everyone's modifying. In Git, you have lots of repositories. Everybody modifies the repositories, and then the changes get reconciled to the actual repositories themselves. And so the reason we're able to actually do this is because a commit, when you make a commit, it is actually a snapshot of the entire directory, if you want to think about it that way. And the way that snapshot is actually stored is as a set of compressed file diffs. So if you change, 1 byte of Rosetta, you change 1 character, the total amount of data stored is, a little bit more than one character. So as opposed to SVN, where when you check out a copy of SVN, it's actually you're sort of storing all of the data twice. So Git working directories tend to take up a lot less space than you might find with SVN. We find that actually storing all of the Rosetta history and a working directory takes up less space than checking out one version of Rosetta in SVN. So it's much more efficient at doing this. And the other thing that everyone having cloned the repository and these commits being snapshots lets you do is it lets you have a non-linear revision history. So you can make branches work on many things in parallel and then merge those branches together. And again, if you've used SVN, you can sort of do this in SVN, but it's incredibly painful to merge your branches. So people tend to avoid doing it. But in Git, it's easy, and it's something you really want to do. It's something we want to encourage. It's sort of the point of Git in the first place. The other cool thing about Git is it's really hard to destroy revision history. If you set out to do it, you can, but it's very difficult to do accidentally. Which is good for the whole backup thing we were talking about before.
If you're pushing back to the remote, aren't you eventually going to have a linear revision history?
No, and I will show you why on the next couple slides. So when I talk about branching and merging, I'll show you how that works. All right, so the first thing I wanted to just talk about is cloning. So when I sent out instructions about how to clone the repository, and you use this script that sort of clones a bunch of repositories and sets them up, and that's because we have certain sort of policies that we want to enforce, and that setup script sort of sets up those policies. If you're just normally cloning a repository, there's this command called git clone. Type git clone and then the path to the repository, and here it's a path on a server at github.com, and the repository is called Rosetta Commons / repo name.git, which doesn't exist. And then it will clone all of this data and make it in a new directory called new repo. All right, so that's what clone does, and this will download the full revision history of the repository, and then it will take the most recent revision and check that out into the directory new repo so that you can actually work with it. So if you were good to go into new repo, you would see all of your files, and then you would also see this hidden directory called .git, and that's the repository, is the .git directory, and then the working copy are the files that you can actually see. So when I talk about working copies versus repositories, that's sort of what I mean. Yeah?
What do you mean by checks out?
So when I say checks out, it means you basically have this repository that has a record of every change that has ever been made. And then when you check out a change, you're basically saying, OK, go back to one of these snapshots and take those files and put them into sort of a human-readable format. Whereas Git sort of stores them as these compressed diffs. It can check out a version of those compressed diffs as files that you can work with.
So it like unzips.
Basically, yeah, that's one way of thinking about it. Yeah. So you were talking about I was talking about branching and merging, and this is sort of like one of the fundamental concepts in Git. So a lot of times you want to work on things more than one thing at once, and even if you don't want to, the entire community is working on many things at once. So having a linear history of revisions doesn't really make a lot of sense. So what branching lets you do is, let's say this is sort of the main branch of Rosetta, and let's say I start here, and I'm like, OK, I'm going to start working on something. So I start working on my project and make a bunch of changes here. And meanwhile, other people are making changes here, right? And so we can have parallel lines of development. And now I can make my changes without interfering with what the people over here are doing, and the people over here can make changes without the ground changing beneath me, right? So I can sort of do my work in parallel. And this is what makes it possible to have lots of projects going on at once. We have this command called git branch. And then here I have the name of the branch's username / feature name. And this actually, I'd like to use this to talk about another feature of Git is what you can have namespaced branches. So if I have my username and all of my branches are named my username / and then the name of the branch, then I can sort of group them together. And that means that I can say only work with my own branches, and then I don't have everybody else's branches cluttering up my when I type like git status or git branch. I don't see like huge lists of hundreds of branches that I don't care about. I only see the ones that I care about. The other thing is it means if we use the namespacing, then this whole string has to be unique, but this part doesn't. So I can make one called my username / new feature. You can have abba / new feature, and it makes things much more reasonable because it allows some categorization. And it doesn't have to be usernames. Really, Git understands that that things separated by slashes are namespaces, and you can have multiple levels deep. You can impose sort of your own organizational system on your own branches, and so you have the power to do that. But That's how the namespacing sort of works. And what we're going to say here is that when you're working with Git with Rosetta, all work you do should be developed in a branch, right? So there's going to be this master branch, and that's going to have all revisions that have been tested by the testing servers. But if you start something new, you don't really want to be developing it in the master branch. What you really want to do is make a branch, work in it, and then when you're done, you can merge. So once you've made a branch, you actually need to check that branch out. So you'd asked about what checkouts do. So there's a command called Git Checkout. And what it does is it takes your working directory and it updates all the files in that working directory to match some version of all of the files in the Git repository. One of the main times that you use Git Checkout is when you're switching between branches. So if I type Git Checkout Master, that will check out the master branch. If I check out Git Checkout username/new feature, that checks out that branch. And then I will be at the latest version of that, the latest version of the files that have been committed to that branch. So you can sort of use it to switch between branches in the repository. The other thing I can do is actually switch to a version that is somewhere back in the history that's not the most recent revision, right? So let's say I'm doing something, and then I'm noticing that something that once worked is now totally broken, and I'm trying to figure. And I'm like, all right, well, I know that it worked last week, so I go back and I look and I say, oh, well, this was the revision number last week when I know this worked. So I say Git Checkout, and then this is a Git checkout ID. They're these SHA-1 IDs, and they're actually much longer than this. But as long as you can use just the beginning of it, as long as it's unique. So you can sort of abbreviate them. And if it's not unique, it will tell you like, hey, this isn't unique. You need a longer, checkout ID. Yeah, you did. Yeah.
So in terms of checking out old revisions, let's say I have a script called run me.
Yeah.
That just runs whatever code
right.
is in repo.
Mm-hmm.
If I checked out a previous revision, will it run?
Yeah, so binaries are not tracked at all. So when you change revisions, you should recompile.
Right.
Yeah.
Okay.
Does that answer your question? Or?
Yeah, it does. So it's in the. So how does it quote unquote know about all that previous stuff? Is it because it checks out all the diffs, or?
Yeah, basically, right. So it looks at so it knows what revision it's on. So when you change revisions, it keeps track of what files need to be changed. Yeah. Okay. Someone else was raising their hand, or no? Okay. So one thing about when you do so. One of the things that makes Git a little bit weird to use is that you tend to have commands that are sort of overloaded, where different commands in different contexts do different things. So if I type Git Checkout Master, I'm actually switching branches. And then if I make commits, they'll be made into the master branch. If I do Git Checkout and then some other thing, it will switch to this revision. But this revision is now sort of in the middle of history. So it calls it a headless checkout. And it will spit out this big message that's a 2-paragraph long explanation of what you've just done. And so the point is, what you've done here, if I can just draw a little bit of a history here. So let's say I've got a branch. We can call this master. If I check out, say, back here, right, I'm no longer at the top of a branch, right? So what will basically happen is if I make a commit now, I'm going to end up in a sort of a new branch, right? This is my new commit, okay? And then the reason it spits out this big message is that if I then, having done this, now I'm at this revision, if I then say Git Checkout Master, I'll be back here, right, at master, and I've left this sort of revision that's not attached to a commit, to a branch.
Well, you said you branched, right?
Oh, well, you made a branch, but it doesn't have a name. So it's just a revision that's sort of floating out in space. And when I switch to master, this revision is still there. However, eventually, once in every couple weeks, Git runs this on its own, sort of does this cleanup process. And when it cleans things up, it will say, "Oh, I've got this commit that's not attached to any branches. It's not needed anymore. I'll get rid of it." So things like this, if you have a commit that is not attached to a branch, it will eventually be cleaned up. The solution to this is if you make some commits and you want to save them like this, before you switch away, you say git checkout -b new branch, and that basically says make the current revision that I'm at a new branch with this name. And in fact, this big long 2-paragraph warning message that it prints out basically is an explanation. It explains what to do, and it says if you want to make this a new branch, type this command, and then you do this, and it will. The reason why this is actually really cool is what it means is that you can, if you're trying to figure something out, if you have something that you've broken and you're trying to debug it, right? You can check out some old revision, make a bunch of changes, and then if you decide that, like, wow, that was a really bad idea, just switch away from it and forget about them, and they'll eventually be purged. So you can sort of make temporary changes without sort of, you can basically make temporary changes off of some old part of history. So does that sort of make sense? And sort of the reason this is sort of, I'm mentioning this explicitly is because it's a case where you have Git Checkout, all three of these Git Checkout commands sort of, from the point of view of Git, they're basically doing the same thing. From the point of view of the user, they're sort of doing really different, conceptually different things. So, and we're actually going to be exploring some of these things when you guys work on the tutorial. So I'm hoping that if some of this stuff isn't making sense now, it'll make a lot more sense when you actually do it. So we want to talk about committing changes, because this is, again, something that's a little bit different if you've worked with other version control systems. So Git has this concept that's sort of 3 tiers of operations. So you have the working directory. Those are the files that you're modifying. You have this thing called the staging area. Those are files that are going to be committed into the repository. And then you have the repository. All right? So if you modify a file in the working directory, there's actually 2 things you have to do. The first thing is you need to take your file that's been modified and move it into the staging area. And you do that with a command called git add. And then once you do that, when you make a commit, only the files that are changed in that are marked in the staging area with git add will actually be committed. And the rest of them will be left modified. This is very different than SVN, where when you commit, it commits all of your modified files. This is actually, while it's an extra step, it's actually really cool, because what it means is, I don't know about the rest of you, but very frequently, I'll be working on something, and then I'll realize, like, oh, shoot, there's this bug here, and I'll fix the bug, right? And then I'll keep working on my other thing. But I have all these files in my working directory, but they're actually relating to sort of 2 separate things. So by only staging some of the files, I can say, oh, well, we're going to stage the files just related to this bug fix. Commit those, right? I've committed that little tiny change, and then I can go on with the rest of my work. So what this makes it possible to do is break up, even if you did the changes sort of all at the same time, like stream of consciousness, you can break them up into little atomic commits, and lots of little atomic commits, which means that it makes it much easier 6 months ago for you to figure out what you were actually doing, or for someone else to figure out what you were actually doing. So that's sort of why this exists. Yeah.
But when you're staging and committing files, this only goes back to the branch that you're in?
Yeah.
Okay.
So when you make a commit and you're in a branch, it will make the commit to that branch, and not right. Exactly. Which is how you sort of keep things separate. Right. The other thing I want to mention, especially to people who have ever used SVN or probably Perforce operates this way too, git commit doesn't push your changes to the server. If I do git commit, it modifies my repository. It doesn't modify anybody else's repository. So that's cool too, because it means that you can sort of make changes without inflicting them on everyone else. But it's something very important to remember, because if you're just making changes, committing, they're never making it back to the community. One of the things that Git script that checkout script that you made did was it added a little warning so that if you have 10 commits that you haven't pushed, every time you make a commit, it'll be like, hey, you haven't pushed recently, you should do that, and it's a big sort of annoying warning. Git doesn't do that normally. That's something we've sort of added. But you want to push frequently. There's really no reason not to. And I'll talk about how to push after I talk about merging. So you had mentioned that you had asked, when I make a commit, where does it go? It goes to the current branch. Well, eventually, right, I want to take my changes and sort of bring them back in line with everybody else. So we do that with an operation called a merge. What merging does is it takes one branch and it combines the changes from one branch with another branch. And it's fairly straightforward. What you do is you check out the branch that you want your merges to go into. So let's say this is my master branch and this is my little new feature branch. Let's say I'm here, right? So the master used to be, let's say this little red commit is sort of the end of master. If I check out master and then do git merge username / new feature, it's going to make a new commit here in which I have merged the changes from username / new feature into master. It doesn't do it the other way. So master hasn't been changed at all. What it's done is it's made basically what's called a merge commit, where it's the changes of this having reconciled with the status of the changes that have been made since you started.
Wait, isn't that a master branch?
The black is master, green is the other things, and most of the changes most of the things that have happened it's able to automatically resolve. It's actually really good at this. Sometimes you have to perform conflict resolution manually. And to answer your question from like 20 minutes ago or something, Eva, where you asked, doesn't your commit history eventually become linear? The answer is no. Because after I make this branch, this shape, this topology is still kept. So even once you've made your merge, you see all of these revisions. You see that you branched here. You see that you merged here. So you maintain this nice nonlinear history, which is cool because it means that later someone can actually go back and see what actually happened to the repository.
But the history in master.
The history in master, so if you read the tree down in one direction, the history in master would be linear. Right? But but this commit to master has two parents. So it is a tree. Yeah?
Yeah, I don't really understand how Git works better than SVN in resolving conflicts. I mean, say that I work on one branch for a year, and then I commit it back to the master branch.
Right.
So I've done like a ton of changes.
Yeah.
I've worked on car functions.
Right.
All of a sudden I try to merge it.
So there's two ways that it's better. One is that Git employs a couple different merge strategies, and I don't have time to get into what they are, but there are different ways of approaching the resolution of a conflict. And it will try a couple of those typically before it falls back to just having you figure it out on your own. And some of those are a bit more sophisticated than what SVN does. And the last slide of this presentation has some links, and you guys will have a copy of the presentation of a big long book that actually explains like exactly what Git merge does. The other thing, and I think this is actually the main reason that it does a better job, in SVN, if you copy a file or move a file, you have to explicitly tell SVN that you've done that, right? And if you don't, if I move a file and with like just the shell move command, commit it without telling SVN, the chain of history is broken. And now if you've been working on that file and try to merge it, you're in a world of hurt because SVN doesn't know what the history was. Because of the way Git stores its information, it is able to tell sort of heuristically when you have copied and moved files. So it's able to maintain that. So it does a much better job of maintaining the history as directories get moved, shuffled around. So it's much easier. It's much better at figuring out sort of what happened to the files in the interim. SVN really only does a good job if the names of the files and the paths are the same, right?
Yeah, but practically, if I work on my own branch, I just have to keep in mind that I should commit like every so often, so I don't like really very often main.
So if you're worried about that, you can actually perform merges in more than one direction. So if I have something I'm working on here, and I know I'm going to be away for a while, and I don't want to completely diverge, because you're right, there's a point where it just gets absurd. You can merge from master into your branch, and you'll be basically updating your branch. And it keeps track of that too. And then you can merge back into the master. So that's what I would recommend there, is if you have something where you're not really ready to merge it into master, but you kind of want to keep up to date, because the mergers are one directional, you can sort of keep your branch up to date by merging in new changes.
So it's sort of like doing,
Yeah, kind of like, yeah. Except it actually keeps track of the fact that you've done this in the history, which also makes it easier to actually do the merge. Because the reason being that if I do a merge from master into my new feature at this revision here, right? Then when I merge, it's like, oh, this is the only revision that I need to deal with instead of all of these other ones. So it makes it much simpler to do. Yeah.
I would say that the point to make is that the merge is happening locally.
Right. That's the other thing. The merges are happening on your computer, so you don't have to talk to Seattle to resolve your merge, which is also better.
Yeah.
Yeah.
I was not sure why would there be any actually conflict, because let's say I checked out something like way down in the
Uh-huh.
branch and then made all these changes.
Right.
And let's say it looks very different from whichever portion in that orange place is, like in the master.
Right.
Now if I'm just going to merge back, and
Right.
I'm getting back into the master, let's say it's very different and I'm just going to overwrite it, right? It's just another step, it's a new revision. Why would there be any conflict?
Well, let me show you here. Okay, so let's say I have a file, and let's say the file to begin with says first line, second line, third line, fourth line. And let's say, in my absence, someone added to fourth line added the word plus, right? And then let's say, in my revision, I just deleted the word line, right? So how do you resolve this? Because they're both equal, right? If I add lines and you delete lines in different places, that's fine. It will resolve that. If we both modify the same line, then it'll go and ask. It'll be like, hey, and what you'll see is in your text file, it'll actually look like this. So it'll say, okay, so in head, that would be the branch that I'm merging into. This is what this line looks like. And then there's an equal sign. And they'll say, okay, in the feature that in the change that you're trying to merge in, the line looks like this. So what do you want to do? And then you can, just by deleting whichever parts of this file you want, you can say, keep this line, keep that line, make some combination of them, so that the conflicts that have to be manually resolved occur when two files have the same line merged, which you're right frequently doesn't happen, but when it does, it will tell you to that. And in the tutorial, you're going to actually be creating a merge conflict and then resolving it. And you're also going to be creating a conflict that can be automatically resolved, and you'll be able to see the difference. And I just explained all of this. All right. So I think we're getting towards the end, and then you guys can actually work on the tutorials. I just want to talk about pulling and pushing changes. So these other two commands called pull and push, these are used to synchronize your remote repository with the local repository. So what I was talking about before is commit modifies your local repository. Pull and push move changes between the remote repository and the local repository. And this is separate from committing. So let's talk about git pull. So what git pull does is it takes the changes that were made on the remote repository and pulls them into into your repository. So it basically updates your repository with changes that have happened in your absence. And then git push basically does the opposite. It takes changes to the remote repository and pushes them. And git push you typically use on one branch at a time. So if I say git push origin new feature, it says, okay, push to the remote called origin all of the changes in the branch new feature. By default, if you have one remote, that remote is called origin. You can actually have multiple different remotes if you want, which you probably don't. But if you do, if you have more than one remote, you would specify the name of the remote. Otherwise, it's always called origin. So what this will do is take all of the changes that have been committed to new feature that aren't yet on the remote, and it will put them there. And if you have done a push and someone else has done a push into this feature before you, it will be like, hey, I can't push this, you should do git pull first. And then you do git pull, it updates. So you have to update yourself before you push, if that makes sense. You have to pull before you push.
How is the pull different from a clone?
A pull is different than a clone downloads the whole new history into a new directory. Once you are in that new directory, pull downloads new changes. Right, git push will push only the specified branch. For some reason, you've changed tons of branches and don't want to type git push 12 different times. Git push origin -- all will push all of the changes to all of your branches. So you've screwed up, and now you want to undo your changes. So let's talk about git reset, which is basically one of the undo buttons. There are three ways of doing it. You can say git reset soft. And what this does is it undoes your commit, but the changes are staged. So then basically your directory will look just like it did right before you hit git commit. Mixed will undo your commit and leave the changes unstaged. So that will be basically what it looks like before you typed git add, right? If that makes sense. So that's sort of backing out one more level. If you think about that 3-level thing, you're sort of backing out one level at a time. And then hard will undo the commit and will discard the changes, as if you never made them to your working directory in the first place. And then eventually, every so often, Git runs this command called git gc, which stands for garbage collect on itself, And at that point, anything you did with any commits you discarded with git hard will actually be permanently removed. So let's talk about this difference between discarding something and really actually permanently deleting it. So you typed git hard and then realized that you totally didn't want to do that. And now your commits are gone and you're panicking. And so there's this other command called Git Ref Log. And what the ref log is, it's basically a record of what's called of the previous head position. So it basically keeps track of every time you checked something out, where were you in the repository? And so if you delete something with Git Reset, and then you can type Git Ref Log and see, oh, well, right before I hit Git Reset, I made this commit. So I can go back here. I can do Git Checkout this, and then make it into a new branch and keep going. So it's really hard to permanently delete work. Like, if you did a Git Reset hard accidentally and then don't realize it until like a month later, you're probably out of luck. But if you make mistakes, you can reset them this way. It's best to do this. It's infinitely easier to do this if you haven't yet pushed. So what you want to do is don't push until if you're in the middle of sort of doing something that you think you're screwing up, you shouldn't push until you sort of have things the way you want them to be. Because once you've pushed, it's possible, but a little bit more difficult to undo things. So a couple things I just want to go over sort of in the interest of harm reduction. Git gives you this whole big set of tools, and many of them are really useful, but many of them, given the way that our workflow is going to work in this community, you probably don't want to do. So I'm going to explain what they are, explain how they work, and then explain why you really don't want to do them. So there's a couple commands that you really just shouldn't use. The reason you shouldn't use them is that as soon as you use them, everyone's life gets really hard who is working with you. Not impossible, but it will just really make everyone miserable, and there'll be like angry emails on the mailing list, and your name will come up in all of them, and it'll be really bad news. So in order to avoid doing them, I think it's really helpful to understand what things are instead of just getting a list and saying don't do this. The reason these commits are bad is that pretty much they all involve rewriting your revision history. And if you've ever watched like a time travel movie or something, you'll know why rewriting history is something that is generally not a good idea. The first thing that you really shouldn't do, there's this command called Git Push Force. So let's say I'm here, right? And let me put it this way. Let's say I'm here, right? And the remote head is there, right? So the remote repository, the most recent commit is here. And what I can push this commit. I would pull my changes. I would do a git pull, and then I would be up to date with the remote repository, right? And then I could do a git push and push this new green one. Does that make sense? So, or better yet, if I was here, right? Me and the my repository and the remote repository are both at this location. They're both up to date. I can now push this change set because it's on top of both of them. It's happened it's happening. It hasn't yet happened as far as either repository is concerned. Does that sort of make sense? Right? I can push things to the remote repository that haven't yet happened to the remote repository. If I'm here and I change this revision, I can't push that change. I can't push changes to revisions that have already occurred unless I type Git Push Force. And then it will rewrite this repository. And now the repository that the change that I've made is now different from, now everybody else's past is different from my past. And now the next time everybody else pulls, things start to get really weird. So you don't want to do this. There are certain rare circumstances under which Git will produce a warning message that suggests that perhaps you should do Git Push Force. And you shouldn't, so just don't. It's really, really not a good idea. Basically, any remote reference has to be an ancestor of a local reference in order for you to push it. And Git Push Force turns that check off and just does it, letting you rewrite the past. The reason why, there is a good reason for doing this. I commit like a gigabyte of binary data and push it because it's 3 a.m. and I'm totally not paying attention. This would make it possible to then delete that large binary from the repository so it's not taking up huge amounts of everybody's space. It's also useful for when you've already completely screwed something up with Git Push Force and you're trying to fix it. But the best way of avoiding all of these problems is just not to do it. So if for some reason you really think you need Git Push Force, send an email to the list and ask, like, I just totally screwed this up. I think I need to do Git Push Force. What should I do? And in almost all cases, you don't actually need to do this. But just don't do it. And actually, all of the commands that I'm going to talk about now, many of them, in order to really break things, you can only really push the changes with the addition of Git Push Force. But the other thing you shouldn't do is rebase. So rebase, if you type git man git rebase, you get this is probably like the worst sentence in the history of documentation. This is their one-line summary of what git rebase does. But basically what git rebase does is if I have a branch, I can rebase this branch onto this branch. And then it will appear, my history will be linear. And all of these commits will appear to have occurred after all of those commits, which in certain cases is useful. But if you're working with lots of other people, it's almost impossible to reconcile these changes, because then you pull and you haven't done this yet, and now we have two sets of commits, and it's just like, don't do it. Right. You use it for linearizing your history, and it rewrites your history. If you want to do it, basically the problem is, if you type rebase, you have to tell everyone who has ever cloned your repository that you just did it. And then because they need to do something different the next time they pull. And there's 100 people in the Rosetta community, and half of them don't read their email, so just don't do it. OK. There's this other thing called git filter branch, which is this completely ridiculous command that basically lets you define some arbitrary transformation to the data in the repository and apply that transformation to every single commit that's ever been made. And when it does this, it actually changes every commit ID. And so you can imagine why this is a terrible idea. But what you can do is you can, for example, do this sort of Stalin-esque deletion of a file from the history, and it will appear that it never existed in the first place. You can change the directory structure retroactively. You can do all kinds of crazy stuff. I've been using it a lot while I've been getting the SVN repositories fixed, but I'm never going to use it again once people start cloning. So I'm just telling you about it because it's in the documentation. If you search Stack Overflow, sometimes people suggest it, but like, don't even go there. All right. So without further ado, we're going to be giving you guys copies of these repository, these what are they called? Presentations, right? And so we've got some really useful things. There's this ebook called gitscm.com/book, which is a really comprehensive online guidebook. O'Reilly wrote this guide to Git that has a bat on it. I don't remember what the actual title is, but you can buy it here, and it's like everything you ever wanted to know about Git. It's really great. If you've been using Subversion, there's a guide written by the people who wrote Mercurial, which is a different revision control system, but it's called Subversion Reeducation. It sort of describes the differences between like SVN and distributed version control. And we've also been putting together a bunch of documentation on our wiki, sort of specific to using GitHub and Git with Rosetta. So that's the end of this. You guys have a tutorial. Has that been shared with them?
Yes.
OK, so there's like lab 1 or something. It's like the Git lab. Basically, what you're going to be doing is making a branch, making changes to it, making another branch, making changes to that branch, merging them, fixing the conflicts, and then pushing it. And so I gave sort of step-by-step instructions. There's a part 1 and a part 2. Part 1 is the thing I already emailed out to everyone, so you're going to start with part 2. And if people have questions, just let us know. Yeah, Yulia.
What's the difference again between checkout and pull?
Checkout, so pull takes changes, sort of synchronizes the remote repository with the local repository. Checkout takes one version, changes in one version from the local repository, and sort of makes them into like human readable files that you can modify. It changes your working directory, right?
Oh,
So pull changes the repository. Checkout changes the working directory.
You actually discussed the difference between pull and batch. Did you do that?
I did not. OK. Yeah. So there is Git makes this distinction between there's the remote branch and there's the local branch. So what fetch does is gets the new changes, and then but it only puts them in it sort of keeps track. Let me draw this. So let's say I'll just get a new thing here. All right. Let's say that I have some history here. And then let's say I've got a branch. All right. So I have one called, master and some feature called like foo. These are my local branches. What Git also keeps track of is the status of the remote repository. So you've got this remote, it'll be called like, origin/master and origin/foo. And this is sort of a special branch that is used to sort of keep track of the remote repository. And this lets it sort of figure out, without talking to the internet, the differences between the sort of your branch and the branch on the remote repository. So when you type git fetch, it will update the remote branches, but it won't propagate those changes into the local branch. So when you type git pull, what you're actually doing is you're typing git fetch, and then, so if you type, git pull foo, right? So you're just pulling the foo branch. We'll do git fetch origin foo, and then git merge origin foo. So it's getting the changes from the remote repository and then merging those into your local branch. So git pull is sort of a shorthand for those two commands. And typically, the reason git pull is its own command is typically you actually just want to do both of those things at the same time. Does that sort of make sense? So git fetch is useful, but it's really not. It's something that sort of you use in sort of special cases, as opposed to git pull, I would say.
So as a summary, git fetch pulls and merges.
No, git pull pulls and merges. Git fetch just fetches, but doesn't merge.
Okay.
Yeah, that's another weird thing about Git is they like to have sort of shorthand commands that combine multiple things together.
Very confusing.
Yes, but once you do the tutorial, I think a lot of this will become a lot more clear.
So for instance, with SVN, if you start doing an SVN update, and you've got code that you've been modifying, you're getting ready to commit it, SVN starts pulling down copies of the files from CI, right?
Yeah.
And typically, the connection dies out, like time out, and then you lose that process, and then you're kind of left with this, like, kind of this in-between state where your modification, like some of your files have been merged with what was on the Seattle repository, some of them haven't, and then you have to go back and figure out how to get everything back to a working state again. That's a little frustrating, right?
Yeah.
So you can think of what Git is doing is in two steps. First, it downloads the changes, right? And then it merges them. And what SVN does is it does that in one step.
Right.
So pull is kind of the equivalent of like SVN update,
Yeah.
except it's still smarter. So
Right.
if the connection dies, and it won't because
Right.
Git, we're using Git up to one.
Yeah.
And then Git is going to, SVN sends entire files, which are big.
Right.
And Git only tells you the difference between files. So it just
And-
has a chain sensitive.
Right.
transfer.
And the other thing, and it's also really good at like not corrupting itself. So if you you're like halfway through a pull and like pull your Ethernet cable out, and then you just type git pull again and it will finish. But if you don't type git pull again, your repository is still useful. There's no there's no equivalent to SVN cleanup, right? Because the reason there's no equivalent is the software has been designed in such a way that you fundamentally never need to do that, which is really nice. It's very difficult to leave your repository in a broken state, although you can.